Alright, so we have this equation, centripetal acceleration is r omega squared. So I have my acceleration, centripetal acceleration. I have my r, I don't have omega. So let's try out omega. Should equal square root of C over r. So it should be my answer. And I can make sure. Yep. Alright, so what is the square root? I know one thing that helps is when we all try it out with our calculators.
Oh.
I know that's
I wonder.
yeah, that's one thing that that's one thing that helps you with your understanding when we all try it out and then we can all work it. Yes, sir.
The 98.8 meters per second. When I put in the calculator, the meters per second won't throw it off. Like I don't worry about that part.
Yeah, it's just
Okay.
it's just that was just saying the acceleration, the centripetal acceleration is 1.5. They said in the question, they just said that it's 1.5 times gravity. So technically, they were just saying that it's 1.5 times g. They said 1.5 times that of gravity.
Oh, okay, I got you. So I got 7 square root 15 over 10. Wait, what?
No, that's just the top part.
Oh, you didn't do it all together.
What?
You didn't do it all together.
I'm gonna break it down. J Mac, what'd you get?
I did it wrong because I put it all in there as a whole.
Which one you put in there? The
You did
14
like that.
square root?
Yeah, just to get used to, putting each thing in. Like even from the beginning, they don't tell you to do 9.8, but they say 1.5 times that due to gravity.
And it's
So even getting
9.8.
used to, one of the things, talking about doing the problems and whatnot is like putting the words to the numbers in the equation. So like even understanding what our known is, saying subjected to a centripetal acceleration whose magnitude is 1.5 times that due to gravity. So now I'm like, okay, 1.5 due to gravity, so I know that's 9.8.
So we gotta find the RPM, right?
And then we might be wondering, well, what about the units? So, for units, we can do that too. Angular velocity, we know velocity should be meters per second.
Ain't get that.
Then it,
What do you do?
see, that's why it's good to check each other.
What you get?
I put in the big number, not. I'm finna type that one in and see if it changed.
What's that? The square root. So I did 1.5 times 9.8.
That's what I did. Hey, did you square it? Or it take it away because it's the square root? What's going on?
Right. So this is the normal equation that we're left with. So and then so revolution per minute, that's omega. The R revolution per minute, that's gonna be omega, because omega is angular velocity.
Okay, I got it when I typed in the small number. But the thing is, so don't put the square in. Don't put in the unit, because you know they say 14.7 meters squared.
Oh,
So you
I
can't
see
put
what
that
you're
in.
saying.
That's how we get the 1.7.
Okay, yeah,
Oh,
that's pretty much what Josh was wondering. So meter per second squared.
That's just the name of the
Yeah,
unit.
that's
So
the unit.
that ain't really going. Okay, so yeah, I typed in 14.7 divided by 8, and then I
Squared it.
the big
Got
number.
you. Yeah, so typically it would have to be parentheses squared.
I kept doing it in parentheses.
Well, as in like if there's a square there,
Oh, okay.
it would go to the value if it has this square connected to it, you know.
Oh, okay, I get what you're saying. If it's on the outside of it.
Yeah.
Okay. Okay.
So remember that. So and then so we get this 1.35. Make sure our units are right. Meter per second squared, and then that's 1/m. So the m's cancel out, and then I get 1/s. Since it's got the square root, then that square goes away too. The square root. So then it's like, okay, 1/s. Why is it 1/s? Well, that's gonna be your revolutions. Revolutions per second. Velocity. Yeah. Because it's saying it spins its occupants the horizontal circular path. The riders follow has an 8-meter radius at how many revolutions per minute?
Revolution per minute.
Mm-hmm. So now, how do you get minutes?
60 seconds, 1 minute.
So I get 81. Revolutions per minute. 81 revolutions per minute. That's a good amount. 1, 2, 3. So that's So if there's 60 seconds in a minute, that's more than a revolution every second. 1, 2, 3, 4. So it's pretty fast.
Yeah,
It's pretty fast.
About to spin the kids off of them.
Pretty fast.
You know, would be. So remind me of anything on the spot.
I think I'm on my calculator. Because when I divide 14.7 by 8,
You gotta then square root it when you're done.
Step.
1.35? We did 14.7 divided by 8. And then you click equal and then you square root it.
I get it. Fraction.
Your calculator is set. So you not change it back. Yeah, it's just in the wrong.
But then I still get 1.8.
What?
That's what I got at first.
14.7.
What button did you choose first?
Yeah, so that's S to B.
Okay.
Yeah.
I'm like, what's your fractions?
So I found there's something that changes fractions. This
That's what I
S,
said.
S
Take it
angle to the or S arrow to the B. Yeah, but it's still no, that's that's still right.
It's right.
So and then do the square root.
You know, 1.35.
So now do the square root of that.
Alright, come on.
1
How
over,
do I do
I
this?
think like 2 eighths or something. Not 2. You know what I mean? Like if she get the fraction, that's just like
Here is
1.35. You think it's 1.35 or whatever. Make it smaller.
Dang, I thought I was gonna change it.
You sure?
How do you
Yeah,
even
you
have
make
it?
it number smaller. You could say 1, and then you could do like whatever 35%. It's not a fraction. Say
14.7 divided by
I don't know
8.
what you divide. Don't go with
And
that.
Now do the square
I
root.
think to divide 35 over
That's what I
107 over 2.
No, that was square.
7 over 20. Okay, easy.
Square root should be
Because still, whatever her fraction number is.
Oh, okay, alright, cool.
Look, she figured out.
Yeah. See, I like that.
Alright.
Cause I was trying to figure that out too. That S arrow with the D. Y'all ever seen that before?
Oh, yeah.
Yeah.
What?
This button
To
right
get the
here,
scientific
S
notation.
arrow.
Right.
The best
No,
of scientific notation.
no.
It should be on there.
This is another type of calculator. This ain't the, I don't got that one. I got this one and the other one, but they don't got it.
Yes, it do. I got that one too.
For mine, it changes the.
It's on the, while you look for your third calculator. I know you ain't laughing, Miss Katie.
Because even when I put it in the mode, even when I put it in the mode right,
Like, I wish you guys had that calculator. Right. Different version.
even when I put it in the mode right, it still
Oh my goodness.
ends up giving us the fraction answer sometimes. So and then there's
Where is that?
18.
I told you, it's no way over there. Say it to me.
Or maybe we could go, let's go to the next section. 6.3,
Probably something else.
28, 29.
Oh, they got F to D.
Okay.
29 and 30.
You know, if you click the second button, it'll take it to whatever the green button is anyway. Oh yeah, I got an F to D.
Mhm.
Oh, it is the same one, so it got the little arrow.
So So now I was looking at 29.
Oh, wait, before you go.
It's got a centrifuge.
Right there, when you're doing the conversion from revolutions to seconds to minutes, what's on top of the 1 minute? What's that? Cosine?
60 seconds.
Oh, I'm sorry.
I see. It looks like a C.
Okay, I got it.
Do a coastline.
Well, I should have known that, but I was not putting the clues together.
No, it makes sense. It does look like a C. There you go.
It say 60, not coast. Okay. Uh-huh.
Yeah. Yeah, it makes
Say
sense.
coast?
So I saw this one because it talks about a centrifuge. And I'm sure y'all would be doing things with centrifuges, or y'all already have from what it sounds like. Y'all have already done some centrifuge work, like the one shown here. So this is a giant centrifuge right here. Look at this. It's like something that they would use at NASA or something.
Yeah.
It's used to expose aspiring astronauts to acceleration similar to those experienced in rocket launches and atmospheric re-entries. At what angular velocity is the centripetal acceleration? 10 Gs if the rider is 15 meters from the center of rotation.
Are we gonna jump into
What is 15
17?
Gs? I mean, what is Gs?
Yeah, I want to just do a couple questions. 6.
Jump into 7.
Yeah, 7 has,
No questions.
you have the,
Like, we need to know what 6.
yeah, we have the homework. You have the homework in 7 as well. And there may be a good way to start off looking at 7 through the homework problem set.
Question about the B2L, because I seen that there's discussions put up, and you still want us to do it, right?
Yeah, that could be a good way to,
Yeah, ain't that next one based off of this one? This
well,
discussion
just
forum?
to like start
Work energy or something?
start looking
Exercise
at,
your brain too.
right,
Yeah, I got you.
and then yeah.
It's gonna tell you what the answer is. So let's go.
So that way I'm kind of like practicing a little bit of a reverse way where I let y'all kind of do a couple of the questions and whatnot, and then we will review it. So that'll
For
help.
me.
Yeah, that'll help. So at what angular velocity? Alright, so it's the same thing.
Is G grams? Is that gravity? 10 what?
That's gravity.
Ground.
Grounds.
I don't think it's 10 grams.
It's not
That's
grams.
gonna be
Something.
that's gonna be gravity 10 times the gravitational
Yeah, it's
force.
like gravity. It's not grams. Definitely not.
10 times okay.
Yeah.
I didn't know we're not
Centripetal
talking about
acceleration.
Okay, so 10 times. Okay.
Yeah, when they talk about in like astronomy and stuff, they talk about G forces.
So they're never going to say 10 times the gravity of whatever. They just put 10 G.
They should have.
Some of them probably
They should have.
Not everyone,
Yeah, they should have.
because it's just like when you write an essay or a new sentence, they be like, you can abbreviate it, but after you say it a couple of times.
It was kind of writing gravity.
So, is this centripetal acceleration? So, let's see here. We got omega at what angular velocity? Question mark. Angular velocity. This is centripetal acceleration. So, this is angular velocity. So So if the centripetal acceleration is 10 times 10g, which, yes, exactly. 10 times 9. Is that kind of hard to see right there? Kind of small.
Is that a C underneath? They,
Yes, centripetal acceleration. If the rider is 15 meters from the center of rotation, which is what? What's 15 meters from the center of rotation?
Are they giving us the diameter or are they giving us the radius?
Yeah, that should be radius. Because diameter
Use what, half
from
of
the
it?
center of rotation.
isn't the diameter the whole thing?
Yeah, if it's the center of rotation, it should be from here.
So radius, okay.
Radius is like that.
Okay, so.
Because imagine without this, because the thing or this centrifuge is connected.
From the center.
Yeah, it's
All I
got
know
that.
is one of them is half.
It's
or
got
one-
that roof.
One of the other, one of
Yeah, it's,
radius is half. Diameter is
Makes a
so.
lot of sense.
so and then
I didn't think I would.
I don't know.
If I read it, like off the bat, I don't think I would have put two and two together, like center of the rotation, that means radius.
yeah, center. Because diameter is the complete. So if it said, sometimes they might say something like from end to end or something, like from your starting position to the pi, or something, to the pi position, or to the makes half of one revolution. If it says something like half of one revolution, I know one revolution is 2 pi. So they might say something like makes half of one revolution. Or they might say something like the complete motion around the curve. Something like that. Or they might just say diameter. So, and
Oh,
then,
okay, cause I ain't gonna lie, you kinda lost me right there. Cause I just now realized you was just doing something on the side, right? Like, the circle in the radius, when it says the center of the rotation, that means in the middle. But what you just wrote, cause I can barely see, I see pi in the circle, so you was just explaining
what they might say if it's for diameter. Like I was saying, if they say like they made half of one revolution, it might be pi. They might say the person traveled half of one revolution, and then I know that that's pi. But then in order to get a full revolution, I know that that's 2 pi.
Okay. I
So that's something to think about.
At first, I'm thinking that you was pertaining to the question, but I'm like, hold on, that ain't got nothing to do with it.
Yeah.
I was trying to bounce back and forth, but I get what
Yeah,
you're
yeah.
saying now.
Yeah. Where's that? Yeah. Sorry about that. Alright. So we got an omega, or we're looking for omega. So those are our knowns and unknowns. So free body diagram. Where's my blue? Alright, so next equation, acceleration. So I know omega or AC equals omega squared times R. AC equals R times omega squared.
Well, what is, look at omega.
Yeah, exactly. So it's the same type of deal. Omega equals the square root of AC over R. And then,
Okay.
so it's basically the same.
So, okay, so we gotta find omega first. So that's gonna be, would that be, do we gotta multiply that, times the gravity already, or is it just the 10 graph?
Yeah, we'll multiply by 9.8. Yeah, 98 meters per second squared. And then R 15 meters. Done it. Should be the same thing. Same type of question. So I get, yeah, I get that too. 5, 6, but yeah, pretty much. So, so now we ask, does that make sense? It does, because this is a large centrifuge, and they're testing out rocket launch exposure. So I could see what's our average, what's a 10G, what's my average G-force? G-force of a rocket launch. During a typical rocket launch, astronauts experience around 3 G-forces of maximum acceleration. So that does sound like a good test for them to do. If it's 2.56, we're very close to 3 G-forces. Revolutions per second in 10. Yeah. Or let's see the speed. To reach orbit around Earth, a rocket must reach a speed of at least 17,600 miles per hour or 4.9 miles per second. Yeah, that's pretty fast. All right, cool. So next thing. Let's go to the next unit. We go to 6.5. Oh, that's it. So that's what that looks